On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, this is example 5 of L'Hopital's rule, and we're going to look at the 0 times infinity form. And if we have an indeterminate form of 0 times infinity, we need to convert this function that we have here to where we have a numerator and denominator, which will hopefully lead to an infinity over infinity or 0 over 0 indeterminate form. From there, we can apply L'Hopital's rule. What does all this mean? Well, let's look at g of x. And let's find the limit as x approaches infinity of g of x. Let's just try to plug in some really big numbers and see what we get. Well, right here, if we let x get really big, x squared is going to get really big as well. Say, for example, x was 100. 100 squared is really big. If we let x be a million, 1 million squared, that's going to get even bigger. So we're approaching infinity for the x squared piece. Now if we take note of this piece here, the sine of 1 over 2x squared. If we let x get really big, this is going to be 2 times a really big number squared. This is going to be a really big number in our denominator, and 1 over a really big number is 0. So we can think of this piece here, this sine of 1 over 2x squared, that's going to be pretty much the sine of 0. Again, because 1 over a really big number gets really close to 0, and the sine of 0 is going to be 0. Therefore, for that second piece, we are taking x squared times this thing. That's going to be infinity times 0. Notice we do have this form, 0 times infinity. It does not matter what order we have this in. So, in order for us to use L'Hopital's rule, we have to write this thing as some type of fraction. Check this out. The limit as x approaches infinity. And up top, I'm going to leave this sine of 1 over 2x squared. And I did just rewrite that x squared. I shot it up to the top, so we have x to the negative 2. But again, this right here, sine of 1/2 x to the negative 2 is the exact same thing as what we have right here. Now, this x squared, we can put this in the denominator as long as we take the reciprocal of x squared, which is going to be 1 over x squared, or we could write this as x to the negative 2. Now, I hope that's not too confusing there. All I really did was I shot this to the denominator, and now we have this rational expression here. And hopefully, it's going to lead to an infinity over infinity or a 0 over 0 form. So let's try this out. Let's let x get really big. This is going to be the exact same thing that we had a moment ago because we did not change this function at all. Sure, I changed the way this looks only because that's going to help with differentiation in a moment. But still, the sine of 1 over 2x squared, if we let x get really big, it's going to be the same thing we have here. So we have 0 up top over, and now remember, x to the negative 2 is the same thing as 1 over x squared. I just erased that earlier. Now, if we're letting x get really big, 1 over x squared, which is the same thing as x to the negative 2, this is going to approach 0. 1 over a really big number does approach 0. So we do have an indeterminate form here of 0 over 0. From here, we can apply L'Hopital's rule. So if you did watch examples 1, 2, 3, and 4 up until this point, L'Hopital's rule from here, we can take the derivative of the top and the derivative of the bottom, and we can try to apply this limit again. So let's do that. The limit as x approaches infinity. Let's take the derivative of the numerator. The derivative of sine is cosine. Let's leave the inside alone. We have to apply the chain rule here, so I'm going to leave that alone for right now. And then we want to come back and multiply by the derivative of this piece here that we just left alone. This is why I rewrote that x as x to the negative 2 power. We pull the negative 2 down. Negative 2 times 1/2 is negative 1. And then we're going to have x to the negative 3 power. We have to subtract 1 from that exponent when we find that derivative. This is the derivative of our numerator applying the chain rule. The derivative of the denominator, pulling the negative 2 down, and then we're going to have negative 2 times x to the negative 3. Again, subtracting 1 from our exponent. From here, I'm going to simplify this. We can cancel out those x to the negative 3's. and we have a negative 1/2 over a negative 2, that's just a scalar multiple. We can pull that out in front of the entire limit. So we have 1/2, the limit as x approaches infinity. And all we have left is this stuff here. Again, after we canceled out these x's and then we pulled that negative 1 over negative 2, making it a positive 1/2, it's going to be 1/2 times the limit of this thing right here. And I'm going to write this as cosine of 1 over 2x squared. All I did here was I shot that x to the negative 2 back to the denominator with that 2. So let's let x get really big now, and if x gets really big down here, 1 over a really big number is 0, so really we're taking the cosine of 0. And the cosine of 0 is 1. So all of this, if we let x get really big, let's make sure we understand this, 1 over a really big number is 0 pretty much. The cosine of 0, that's equal to 1. So all of this, the limit as x gets really big of this thing is just 1. And therefore 1/2 times this limit that we found here to be 1, our final answer 1/2 times 1 is 1/2. And now let's verify this answer over in Desmos. Here's our function, x squared times the sine of 1 over 2x squared, and we were letting x get really big. And if I take this pointer and I start dragging and x is getting bigger and bigger and bigger, you'll notice that this y value is 0.5. Now it's probably like 0.499999 or something like that, but Desmos is rounding it. And if we just keep on going, it's going to be that same limit of 0.5, as you can see right there. And there you have it, a 0 times infinity form. The trick here is to somehow hopefully be able to rewrite this thing as a rational expression like we did right here. And hopefully that will lead either to a 0 over 0 form, or it could be an infinity over infinity indeterminate form. And then from there we can apply L'Hopital's rule because of that, which will possibly lead to some limit. And in this case it was 1/2. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.